This is Electromagnetism, section 2 of the revision package for separate physics. We're going to look at the basic stuff about electromagnets, which hopefully you learn in Key Stage 3, but you'll certainly have had a chance to revise during Year 11. And we're going to look at the new bit for Year 11, which is the motor effect. So we're going to look at factors that affect the strength of an electromagnet, how to change the direction of the force on a wire carrying a current in a magnetic field, and then, as it says, it's the motor effect, so this is how this is used in a motor. So we have to just make sure remember some basics first, otherwise the rest of it won't make any sense. So just to make sure we're clear, all magnets have two poles, a north pole and a south pole. If you put poles together which are the same, they repel, opposite poles attract. Not very many metals out of the periodic table are magnetic. Iron is far and away the most common one. You might come across nickel, maybe cobalt, and then there are some what they call rare earth metals, which are very rare and hard to find, getting very expensive. And then we can draw magnetic fields, and the rule for those is the lines go from north to south. Okay, so once we've got the basic stuff out of the way, we need to move on to electromagnets. So the first thing to understand is that any wire with electricity going through it will create a magnetic field. So if you've got a wire going through a piece of paper and you sprinkle some filings, iron filings around there, you'll find this circular pattern, okay, which is a magnetic field around the wire. It's quite hard to do that because it's a very weak field, so you won't find electromagnets normally just made out of one piece of wire. Okay, what we do to strengthen the electromagnet, okay, is this kind of arrangement. So we form a coil, sometimes called a solenoid, with the wire, and the three crucial things to remember are the ways to make this electromagnet stronger. Okay, so one is to increase the number of turns of wire that are on the coil. Okay, remember there's only one coil. Okay, what we're saying is that there's a number of turns on that coil. Okay, we can put more current through the wire, and we can put an iron core. This sort of concentrates the field if you put a magnetic material in the core of the electromagnet.